Okay. Well, I think I'll start so I can keep us on track and I'll add folks in as I see them pop up on Zoom. But thank you again for being here today. I'm Rachel Eaton. I'm one of the fair directors for the Oklahoma State Science and Engineering Fair, and I'm based at OSU and in the College of Arts and Sciences is my primary role, where I serve as the program director for research engagement. And so I'm really excited to be here with you today, and I'll just add Nicole. She's just joined our Zoom. Perfect timing, Nicole. I just introduced myself. If you would like to introduce yourself as well, that would be great.
Good afternoon, everyone. I'm Dr. Nicole Colston. I'm a teaching professor in the Honors College and a co-director with Dr. Eaton on the Oklahoma State Science and Engineering Fair. Excited to have you on. Hi, Jason. Hi, Deanna.
Thank you, Nicole. Thanks for joining us. I'm really glad to have Nicole as my partner in running this longstanding, wonderful program that we are new to leading, but we get more and more excited about it every day. Oh, and I realized, Nicole, I need to fix your email address here. It just says @email, so that's not going to go anywhere. I'll update that before we share these materials anywhere. But other than that, there's some contact information here, and I will now take us today through a little bit more about what this program is, and then through some of the rules, which is the key goal of today's session. We picked this event for this time of year because, for the most part, students are starting to organize around what their projects might be. And an important part of our program is that we are affiliated with an international competition and we abide by those rules. So before we get into the details, though, some information about the upcoming season. So the 2026 OSSEF will be Friday, March 27th. It'll be a one-day event again. Registration will open, I have January 12th here. It will open earlier than the regional fairs. So students will, of course, qualify out of a regional fair, and I have a slide about that as well. But the big things to note is that it'll close. Oh, I extended this. Gosh, sorry. Got
Yeah, it
lots of
was,
typos here. I extended this to February or to March 3rd. So this event goes until March 3rd, the registration period. I got ahead of myself and then I updated things and then I didn't get back to this. Okay. So then, yes, we have a later fair this year. So those of you who have participated in the past might realize that some of these dates are pushed back. So we're at the end of March for our OSEF and we are March 3rd for the registration deadline. Students basically have until very close to the actual event to respond to any updates to their registration that our scientific review committee will request from them. So this is another updated slide I'll make before I pass all this along. But the fair date is correct, March 27th. Okay. So like I mentioned, this fair has been going on since 1958. We are digging into the details of this program in our state, and so we're rounding the corner of the 70th Oklahoma State Science and Engineering Fair. It's been around almost as long as there's been a national science and engineering fair in our country. And so Oklahoma has a long history of partnering with what's called ISEF, the International Science and Engineering Fair, and it's currently sponsored by a company called Regeneron. And so being an ISEF affiliated fair is important to us. It puts our students and the research that they do and the teachers that they have and the mentors and STEM experts that they work with on a national and international stage. And it opens opportunities to them that would not be there in quite the same way if we didn't have a link in this chain of this large international fair network. So I'll talk about it in a minute, but because we are partnered with this international fair, our students get to compete at the international level, which is exciting. So we follow their rules and guidelines. The rules and guidelines are linked to ISEF from our Oklahoma State Science and Engineering Fair website. But when in doubt for a student or a teacher or a parent, going to the rules at the ISEF website is what you want to do when you're wondering about your project. And then if you need clarity, we're always here to help answer questions. We have social media for our fair, which has more information and highlights as well. And the registration process and the paperwork review process and our judging process all happens on a platform called zFairs. And so that's a bit in the weeds for this moment in the year, but when students qualify for OSSEF, they will get more information about how to use that platform for their registration. The fair system in Oklahoma sits on the shoulders of 8 regional fairs, and those are spread for the most part around the state. I have a color-coded system here to show you which counties roughly equate to those 8 regional fairs. There's not currently a regional fair in the southwest part of the state, but if students in that area want to participate, they're not prohibited from doing so. They would need to go to their nearest regional fair. And we can help facilitate those connections if need be. But those regional fairs tend to happen in the mid to late February timeframe, and students can direct enter in those regional fairs, meaning they each have their own website or Facebook page that will give instructions for how students can register their project at that fair. Through competing at the regional fair, that's how students will qualify for OSSEF. So you cannot direct enter to the state level competition. We have a regional feeder fair system here. Some schools or local um, groups or smaller scale than regional fairs might also exist. We don't have a comprehensive list of that. And so it can be helpful in a student school or region to talk around and ask questions and find out, can I just direct enter into the regional fair, or does my school have a fair that I need to qualify out of? I think that's not as common as students just registering for a regional fair, but there are a handful that exist at the school level. So like I mentioned, the exciting thing about being affiliated with the International Fair is that every year we get to send some of the Oklahoma students on Team Oklahoma, I'm wearing my Team Oklahoma jacket today, to be at this international competition with 1,600 students from 65 or so countries around the world. They get exposure to top tier scientists and engineers from around the world that come and exhibit to them and give plenary speeches and have networking sessions with them. The best colleges and career opportunities are there recruiting these students. They get to exhibit their research with peers that are their same age on this huge, wonderful exhibit floor with innovation and creativity and that like youthful energy. That's a really exciting thing for them. So we love that we get to be a part of the international fair system so that those Oklahoma students get to have that same experience. So the top 3 senior division projects, high school age projects this year will be going to Phoenix, Arizona in May to compete as part of Team Oklahoma. The state level competition and some of the regional fairs send students to that international fair. And so collectively we comprise Team Oklahoma. At the junior division level, if you have younger students that you work with, they do not get to go to the international fair, but there is a national competition that they are eligible for. So every year we get to put forward names of the top 10% of our junior division projects, and they get to submit their work for a virtual competition called the Thermo Fisher Scientific Junior Innovators Challenge, JIC. And we have every year a couple of Oklahoma students that advance in that competition and make it to the top 300 and get that national recognition, again, of science and young STEM talent in Oklahoma, which we love. Each year we put out a sheet that gives a little bit of an overview of who was part of this program in the last year. So we had just under 200 students. Our goal is to go well over 200 students participating this year. So please spread the word about this science fair program to those in your networks. It's roughly equivalent in terms of senior high, junior high, and they can compete on teams, which is why the student and the project number is different. I'll share more about that. Right now, 40 schools across 24 counties in our state participate. We would love to see that grow. That's 45 teachers that are working alongside these students. And we also have well over 100 judges, STEM experts, professors, graduate students who volunteer their time to come to OSSEF, to come to our science fair and spend the morning with the students and hear about the work the students have done and ask them questions and give them feedback and serve as an embodiment of what one could aspire to by continuing in the STEM field and continuing in their education. So we are not restricting ourselves to OSU folks for judges or volunteers. So also share widely. We welcome judges from all over Oklahoma. Our categories are listed here on this pie chart. Excuse me. Some are larger than others. In the last few years, earth and environmental science, behavioral science, and kind of the biochemistry fields have been larger, but we try to cover all disciplines of STEM, including engineering, of course, and social and behavioral science. Worst time to get a tickle in your throat. Here's some fun pictures from last year at the ISEF 2025 in Columbus. This is Team Oklahoma in their jackets, students from all over the state, Tulsa, Northwest Oklahoma, Oklahoma City area, Norman, Stillwater, a great team that went and represented our state on behalf of all of us. Excuse me. We had three students that I'll highlight here, Andrew, Alex, and Jonathan, who were part of Team Oklahoma that actually did, on the night of the award ceremony, get recognized in front of these thousands of people from around the world for their research project. There are awards for best in category, and there's also what's called special awards where sponsors can have some kind of niche interest that they might want to shout out for um, prizes and scholarships and additional recognition. So we've had category winners and special award recognized students as well. Okay, that was a bit about what OSEF is and what it's been up to lately. And now we get into some details of the rules. This will be more, of course, than anyone can learn in one setting, but we wanted to offer a new way of sharing the rules and guidelines through this session. And so we'll talk through some things today. You've heard me mention our junior division and our senior division. They compete separately from one another. So junior division was 6th through 8th grade, and the senior division is 9th through 12th. Students can participate either as individuals, where they alone present their project, or they can have worked on a team of 3, where they're working on the project together and they present it together. So pairs or teams of 3. Everyone needs to follow the ISEF rules and guidelines. They need to follow local, national, state laws and policies and not be breaking any rules. And it is ultimately up to the student, the adult who's supervising them, to know what the rules are for the project that they plan to do and compete and to follow them. For a given year, they can only do one kind of 12-month period of research. They can't have started the project any earlier than January of the preceding year. So for the projects that will compete in 2026, that means January of 2025 is the earliest that they can have conducted a project that they plan to compete this year. Students are allowed to present continuous projects from year to year, but there has to be a change, an additional variable, or something meaningful that expands on previous year's work. They cannot just keep doing the same thing year to year. And there's additional paperwork that's required to document that distinction. Form 7 is mentioned on the slide here. I'll talk about the forms a little bit one by one as we go. So the International Science Fair, along with their very specific rules, has very specific registration forms. And we've gone through this genesis of we use the ISEF forms, we try to simplify, and we're back to using them. And our board agrees that for a variety of reasons, including simplicity and alignment with the International Fair and preparing younger students for eventually having to do the complicated forms anyway, our mission is going to be support students and teachers and parents through completing the forms, but require the official ISEF forms. And so the forms are year specific. Sometimes I've seen registration materials come in where it's clear they've found PDFs that they've printed and filled out from a year that is not the current year. So be mindful of that. You need to have the 2025-26 forms. There are sometimes changes between years. There are certain forms that all projects require. This is the lower number of forms. And essentially, these are documenting who the student is, who the adult sponsor, which is the terminology for like the adult person overseeing this project is, what the name and type of the project is, and then the detailed research plan. Based on what the project is, there will be more forms required, but just knowing that forms 1, 1A, 1B are required, a written narrative of the research plan is required, an abstract and a photo of the project will be required for our fair. I'm also being more upfront about what's called Form 3. That's the risk assessment. There's some level of risk in every single project, whether that be to the student or the human, interactions of that student is working with, the environment sometimes. And so I am really recommending that to simplify the process and to make it easier on our scientific review committee to ensure that rules were followed and appropriate scientific conduct took place, that encourage students to complete a Form 3, a risk assessment each time. ISEF has fillable forms. And so if you follow their link, which we also link on our website, you can work on filling those forms out and print them instead of handwriting. There's also supposed to be a new feature in our ZFairs registration software this year that if you are filling the forms out for the first time in registration, that you can type things in there and request digital signatures all within the ZFairs registration software. That was mentioned to me in a conference, and I need to get more clarity around it. But like I said, we will have a kind of a packet and a handbook that we're putting together for student qualifiers, and those details will be in it when it comes time for students to actually register. We also have a step-by-step guide to help with the forms. We're doing our best. We're happy to answer questions about forms. We know it's a lot. We want to point to as many resources as possible to get through form filling. Okay. OSSEF and ISEF are clear on the ethics that the students have to abide by. And so scientific fraud and misconduct are not going to be allowed. This needs to be the student's own work. Any use of outside data or background information needs to be clearly cited. They should not be using AI to generate materials for their project, but only as an educational tool. And if it's revealed in some way that projects are fraudulent or violate the ethics policy, that could be grounds where they're disqualified from competing. It's important as well if a student has a scientific mentor or a STEM professional working with them, that the student is only submitting their work, not just regurgitating something that this senior level advanced person has done. Another source we have back to the forms is this flow chart. It can be helpful as you're thinking through what kind of project the student has. The purpose of this chart is that it will let you have a little more clarity on which forms will be required. This is just to mention the resource. It's available on our website. Okay. ISEF breaks their rules down based on some key types of studies. And the first one that they really get into is what they call human participant studies. Studies where the subject of the research are people. And so these are common ones include if the participants are doing some kind of physical activity, if the student is administering some kind of survey or questionnaire or test and humans are completing that survey, that's a human participant study and needs to follow human participant rules. Online surveys are possible. Consent is still required. And with all human participant studies, a key thing that have to be demonstrated is that there's a consent process in place. Another type of human participant study that students often don't realize is that the researcher themselves is the subject of the research. That's still human participants. Sometimes the engineering leaning students might be doing an invention or a prototype or an app. If they have someone test it, if anyone other than themselves tests that app or prototype, that becomes a human participant study and additional rules and forms are layered on. If they're the only one who ever tests their app or they're the only one who ever puts the robot hand prototype over their hand, then there's exceptions there. But anytime someone else is introduced, you've kicked over into a human participant study. Sometimes students will do projects where they want to observe at a public place, like go to a park and see, this would be an overly simplified project, but something like how many people went down the slide versus played on the swings. If they're not interacting with the people, if they're not putting up a sign that says, try the swings or something like that, then that is not an interference into what people's behaviors are, and there's exceptions allowed for that type of study as well. But if they're posting a sign or asking people why they picked the swings or the slide, or they're conducting some kind of research in a place that is not a public space, um, then that kicks into human participation studies and forums. For folks who have been involved in science fair in the past, there's some notable updates to the human participant rules. One is that they cannot be sharing any results of their data with the subjects of their study. They just need to get the data and then, hold on to that for purposes of the project. Another new and potentially impactful rule this year, because we see a lot of projects where students might ask the teacher, let's say, to distribute a survey to the class or to other classes for purposes of one student's project, is that if there's any study where a minor does a survey or is asked to take a test or is asked to compare Coke and Pepsi or something like that, then there must be written parental permission from the legal guardian of every student who is a subject or a tester or a survey completer for that project, as well as the student's assent. So that's going to add a layer that needs to happen before a project, before experimentation day or survey day or whatever it is. These parent permissions need to be in place. Similar to that, if students are going to do some kind of human participant study in a type of facility where the people live there, or if they go to this particular place for programming, so examples listed here are be like a retirement home or a daycare facility or a prison. In addition to the informed consent of each person in the study, they need a written statement or letter of the person overseeing that facility, someone who's in charge and said, I have given permission for this student researcher to do the research at my facility. A little bit more details about the form. Form 4 is where the human participant forms start. Human subject studies need to have pre-approval by an institutional review board, an IRB. I'll explain a little bit more about what needs to go into that IRB later. If a student happens to have access to a mentor at a university or other regulated research institution, the university's IRB approval process has to be the one that's followed, not from the student's school. Depending on the subject, these human studies will also need what's called a qualified scientist form. Something to take note of, if the student is filling out the form where they're listing the people at their school that were the IRB that reviewed their project ahead of experimentation and said it was followed the rules and was appropriate for human behavior studies, there's a line on there that says educator. The person who signs off as the educator on the IRB should never be the teacher supervisor of that same student's project, because that's a conflict of interest. So be paying attention to some of those congruencies. If you're supervising the project, you can't also be the one saying, I am the external reviewer and I approve the project. There's a conflict there. Another key thing that happens, not so much with our fair, but it is a larger problem sometimes, but we want to be on the lookout for it. Students should never be creating an app or a tool or something, or directly providing any kind of advice or medical information. They have not gone to medical school. They do not have the training or the authority to do that. That includes publishing their app. So if they say, we made this awesome app, it can help take pictures of spots on your skin and potentially, diagnose skin conditions. If they said, and then we put our app on a website, that is in violation of the rules, because almost exclusively the students will not have had the appropriate FDA approvals for that app to allow it to be out in the public domain. So if your students are going to create some kind of medical type app or device, don't put it on the internet, or you'll have been over the threshold of what is allowed and legal. Okay. There are a lot of examples of human participant studies. I think we've covered a few of them. There's a few more here. If they have a data project where for some reason the data itself has not been de-identified from the person affiliated with those data, maybe it's medical data or something like that, then that becomes a human participant study because of the connection between the data and the actual individual person. There can be some exemptions to human participant study rules. For example, um, this is in like an overly specific table that's showing when would certain forms be required and when would they not. We covered some of the examples already. The main ones we see is that the student creates something and then they have someone else test it. That's no longer just an engineering project, for example, that becomes a human studies project as well. The next major category of rules that we follow is for vertebrate animals. Some updates for this year. Cephalopods, so squid and octopus animals, are, for the purposes of the rules, to be treated as vertebrates. And so vertebrate animal rules will need to be followed if the student's working with squid or octopus. There are some restrictions around fishing for the purposes of the research project. They cannot use barbed hooks and they cannot use electrofishing equipment for the purposes of the research project. And then there's been a clarification about animal tissue. If they have access to animal tissue from an animal that was euthanized for a separate purpose, so let's say for a purpose at a university research project, but then the high school or middle school student is able to do their project with that tissue, it's considered a tissue study, and we'll get into that details here in a second. They do not have to do the vertebrate animal piece because they were not involved with the actual working with the animals. It was exclusively for the student researcher, a tissue project. Anytime the student's working with vertebrate animals, those are the Form 5s that we're talking about. There's two distinctions. 5A, if the student is at home or at school or out in the field on the ranch, there's one form that they'll follow. And then again, if a student is at a research institution or some other location that's not their home or their school, there's a separate Form B that has to be followed. Pretty much all vertebrate animal studies need to have pre-approval for animals. It's not an IRB that's exclusive to humans. It's the SRC, the Scientific Review Committee. If they're working at a regulated institution, there's the Institutional Animal Care and Use Committee, IACUC, that will be the one approving the larger study that that student is a part of. For these type of projects, the Qualified Scientist Form 2 is probably required as well. Some big things to keep in mind. They cannot do anything that causes pain or distress, certainly not death to animals in their study. And that is things like distress would be relative to the animal, right? So one example that our predecessor used to give, or we saw, I know I saw it in some materials earlier, is that you can do a study about fish swimming because that's not stressful to them, right? But cats don't swim. So a study about how cats respond to swimming, different types of stress. So paying attention to what's appropriate for the animal in question. Sometimes some of these kinds of studies are allowed by a person's mentor or the graduate student that might be supervising a high school student, let's say. And it's allowed at a research institution, but it is not allowed for purposes of the student researcher science fair competition. The next big category of projects is the PHBA, potentially hazardous biological agent. And by and large, we're talking about bacteria, sometimes viruses, and things of that nature. Big clarification for 2026, students cannot use anything to do with prions, no prions themselves, no prion-like proteins, and there's a detailed list on this slide and in the ISEF rules about implications of that. If they have access to some animals or tissues that can have been bred to express prion-like proteins, that is allowed, assuming that they are at an institution, a research institution, and they're in a biosafety level 2 lab. The type of conditions in which they conduct their project are going to be determined by the type of microbial agent that they're working with, and students have to follow the proper safety conditions throughout the duration of the study. So an example that's come up in past projects is they might say, okay, well, my lab is a biosafety level 2 research lab, But if that's true in a fume hood with proper exhaust and barriers from splashes and things like that, but the student is conducting the research out on an open lab bench, then there's a mismatch in terms of the safety level that the project is actually conducted under. So the safety conditions need to be in place throughout the whole study. Harmful algal blooms are biosafety level 2. Certain pathogens like malaria and Lyme and insects are biosafety level 2. And most, certainly not home, is biosafety level 2. And most, I think, high school labs, middle school labs are also not biosafety level 2. But there's more detail and resources in the ISF rules about figuring out what safety level the student's research space is. Right, so bacteria, funguses, parasites, some other examples, rDNA technology, animal tissues, blood, body fluids. The Form 6s are the ones that deal with these biological agents. They will almost always require pre-approval. So that should mean before the experimentation takes place. These projects should be written out in a way that they follow all rules, and the scientific review committee, usually in our system of the regional fair where that student will compete that project, should be able to approve, review all the materials and approve. And so by the time it gets to our science fair, it's been competed once. It should have been reviewed prior to experimentation by a scientific review committee. And then our scientific review committee will look at it again to make sure that we're not bringing anything to our competition that has violated the rules that we agree to follow by being affiliated with the International Fair. There's some additional forms. Form B is related to human or vertebrate animal tissues. This will often require a Form 2 depending on what the project is. Some key things that jump out in this space: they cannot culture microbial agents at home, so they can't grow bacteria at home, they can't grow mold at home. If they're going to swab things and have them on Petri plates or in vials or any kind, that has to be in some kind of safety regulated lab. So biosafety level 1 or 2, depending on what the microbes are. If they are going to swab something, the school drinking fountain, the bathroom door handle, the keyboard, and then try to grow what's on that, that means they're growing unknown bacteria, potentially dangerous bacteria, we don't know. But as long as they seal those plates, they don't reopen them, they properly seal them, tape them off, and observe the growth, it can be considered biosafety level 1, and most school labs would be sufficiently zoned for that. But if they're opening things up, then that's a whole more complicated and serious level. So they have to keep those plates sealed if the bacteria cultured are unknown. And then following proper disposal rules is expected as well. For all of these types of rules, there's a short list of exempt studies. We don't have the space to go through all of them here, but I will point out some resource, like I'll click on some tabs when we're done here of places that you should be going to look for the details, and you can bookmark these places. And sometimes there are exceptions to the real complicated forms required and approvals, but it's important to know that ahead of time and not make assumptions. Okay. Then the next category of rules is hazardous chemicals, activities, or devices. So this is a lot of chemistry projects, primarily. There's been a long list of, or not really a long list, but there's been some new clarification over how different chemicals are classified based on things called the globally harmonized system. It's a lot of detail. It's best read in the rules than gone over here, but essentially, ISEF has separated and redone some of their rule book this year to try to make it easier to understand what exactly is the rule, what documentation is required, and what kind of approval is required, and what kind of studies are prohibited. And so hopefully going through the rule book is easier now than it has been in the past. A big thing for chemical-based research for our students is that the students and the teacher, or whoever is the adult supervising person, need to be mindful of minimizing the impact of that chemical experiment on the environment. This means paying close attention to what is the proper disposal procedure, safe disposal procedure for whatever those chemical products or materials are. We've seen students get into trouble where they're building on a past study that had a certain kind of protocol and certain kind of approved disposal procedure, but their project was increasing the concentration or doing more chemicals in a sense. And so then they didn't think through that the approved disposal procedure was no longer appropriate. And so being very careful not to violate basically federal environmental law by dumping things down drains or out in the woods or something like that. So be mindful of those things. Paying attention to safety is important. Certain chemicals that have relatively lower risk levels based on like this GHS system, as long as those are being used for their intended purpose, those projects can be conducted at home as well as school or research institution. But if there's something happening with the chemicals where they're not using them for the intended purpose and there's something more complex going on, then that cannot happen at home. Risky research we are not usually allowing, and if there's flexibility, we're strongly discouraging doing those research projects at home. Okay. So there should be good practices in place for handling, safety, ventilation of chemicals. They should know how they're to be disposed. Some things that can come up if they're doing some kind of at-home experiment, but they're using like their household cookware utensils for the project, they cannot return wash stuff up from their chemistry project and then put those back in the drawer for further cooking. Stuff needs to be disposed of after it's part of the chemistry experiment. Chemistry projects, whether they be at school or at home, someone who is an adult with proper training and knowledge of the chemicals being used should be directly supervising. And direct supervisor is a proper noun in science fair lingo because that's the person with the technical knowledge and the safety wherewithal to appropriately supervise this project. So we cannot be turning students loose at home or at school without proper supervision and safety plans in place. What does that mean for us? That means in the research plan, we're going to be looking for our scientific review committee, which is made up of science and education faculty, are going to be looking for in detail ways to ensure that the student was conducting their project safely, that proper disposal and mitigation of risk related to chemical handling is in place as well. And so doing one's best to ensure the details are in the student's research plan ahead of time will make the competition approval process and the scientific review process down the line much smoother. Okay, I mentioned a bit at the beginning about how I like Form 3. This is the risk assessment form. Sometimes students think that their project involves no risk, but that is probably not true across the board. And so there are some projects that require a Form 3, and that's what's listed here. I recommend a Form 3 for pretty much all projects. So things like if they're working with prescription drugs, alcohol, tobacco, firearms, explosives, any kind of chemical or activity that is a higher risk level than what the student would encounter in any daily life, including lasers, Form 3 would be required. Clear explanation of risk and how risk is going to be mitigated and what personal protective equipment will be used all goes into that Form 3. Form 3 will also be required if a student designed some invention, but then a human other than themselves is testing it, or even if themselves are testing it, we need to know that this person that we're paying attention to the potential risks of testing a student designed invention because they are not experts, they're students. When the students are working with bacteria and mold, there's the specialty forms related to the biological agents. But depending on what else is involved in the study, other chemicals or other things related to the study, a risk assessment Form 3 might be expected as well. Projects are going to require adult supervision. They're going to require, in some cases, a qualified scientist who has the specialty knowledge needed to safely and appropriately conduct that project. People are going to have to sign and agree to say, I am the adult sponsor on this project, or I am the teacher on this project, or I am the qualified scientist. And so we're doing this kind of information session and rules review this early in the school year because it's the time of year when project ideas are taking off and plans are being made. And so knowing what's expected well ahead of time, knowing that approvals have to be in place, and you don't have to have signatures by a certain day, but you have to have had the conversations where people are approving things and plans are in place for students to be monitored as they do this project, depending on what the risk level is. All of that should happen early. And so, again, it's up to the student and those adults that are working with the student to make sure rules are followed and safety is paramount. All right, I've been using a bit of terminology. One of those is RRI, Regulated Research Institution. If a student is working at an RRI, which for all intents and purposes is usually some kind of university type setting, college setting, um, business could fall under this as well. Anything other than their own school, their own home, or maybe the ranch or out in the field. Then there's extra paperwork. A Form 1C is required where there's details about who gave them permission to work there and who was watching them and supervising them when they were working there. Whoever is filling out that 1C, the person giving the permission, has to be some kind of supervisor or someone with the authority at that university or place of business to sign off on that student's participation in that location. A Form 1C is required even if a student is working remotely with, let's say, a university professor. And so it's not only required if a student physically goes to a regulated research space. It's a good idea to also have a letter with specific permission described and the details described so that the student has added documentation signed and dated that they have permission to work in a certain location and were monitored. I'd like to point out 3 common project warning flags. If you have students who have something that interests them that's going to have them be working with human subjects, human participants, stop, make sure the rules are clear. We're happy to ask questions. Regional fair folks should be able to answer questions as well. Although I will mention not every regional fair affiliates with the international fair, and so their rules and their obligation to the exact same rules that the state fair follows might vary. But we are here to help if you want to ask us any questions at the OSSEF at okstate.edu email address. We are happy to do that. They're already starting to come in from some teachers, even this year, with some clarifying questions. So yes, if your students want to work with human subjects, pause, make sure everyone's clear on the rules, and know that before the project begins, that IRB, Institutional Review Board, needs to approve. If they want to work with any kind of animals, vertebrate animals, they need prior approval. They need Form 5. Make sure they're clear on the rules. And if they want to do any kind of microbiology work, it cannot be done at home. And there are specific rules, of course, and forms associated with that as well. Again, requires prior approval before experimentation begins. I feel like I should have put these terms at the beginning since I use them so many, but the IRB, we've said it so much, is the Institutional Review Board. For our purposes, there is on Form 4 a space where the Institutional Review Board, often at the school level or the regional fair level, whoever's giving that prior approval will sign off on that. There are expectations of the types of folks that are to comprise an Institutional Review Board. There needs to be a school administrator, which is preferably at the assistant principal, the vice principal, or principal level. There needs to be someone who is trained and licensed in the medical or mental health profession. For example, a registered nurse, a licensed social worker, counselor, a physician, someone who has the authority to look at the student's project and has perspective on potential risks for the human subjects involved. And there needs to be an educator on that institutional review board. Big note, like I mentioned, make sure that whoever is the supervising teacher of the student is not also trying to sign off on that educator line. There is a section to mark if the student is having the project done at a research institution. Like I mentioned before, institutional IRB is required, so the student would provide documentation that they have institutional approval to do that work, and then the folks reviewing the actual paperwork would review that alongside the rest of the student's paperwork package. There should be no conflicts of interest on the IRB, meaning the student's sponsoring adult, the person who's overseeing their project, the parent of the student, any close relative, someone who's directly supervising the research. These are all specific terms, but or their qualified scientist or mentor if they have one. None of those people can be on the IRB for that student. The companion to the IRB is the SRC, the Scientific Review Committee. These are the folks that will give prior approval on all those vertebrate animal projects, all the microbiology type projects, blood, bodily fluid type projects. They almost always will require prior approval before experimentation. That committee, if it's formed at the school level or regional fair level, needs to have 3 people as well. One of those is a biomedical expert, meaning a graduate level degree, professional degree in microbiology, biomedical research, or related field, or the equivalent experience to have that level of expertise in biomedical microbial research training, an educator as well, and one other person, where that it's more flexible what that person's background is. One person who's acting as chair is responsible for signing the forms on behalf of the SRC, and again, avoid conflicts of interest between the student researcher and whoever is signing off on the SRC for their project. Again, if they're doing research at a research institution, like ours, for example, if it's OSU or one of the other colleges, as an example, the institutional committee that oversees vertebrate animal research for that whole college, university, research institute, what have you, supersedes, and they are the ones who have to sign off and who have to provide documentation that the project that the student is a part of has been reviewed and approved. Okay, I have time for questions, which is good. I was worried I was going to talk even longer than that, but overall, we are excited for the 2026 season. This QR code will take you, I'm going to show you a couple of places on our website. We're working on simplifying our OSSEF website, so you might notice it change a little bit, but basically osef.okstate.edu gets you to our website. And for students and teachers, the first place you think you want to go is the Students tab. Right now in the Students tab, it's got 2 main areas of interest. Project rules and displays guidelines are here with the link to the ISEF rules and forms. And the project materials, this is more for students who qualify. It explains exactly what they have to produce to compete. Forms and registration guidance. The step-by-step forms guide is an annotated package of all of the ISEF forms that essentially points out some common problem areas that pop up. And so it gives a little bit more insight into how to fill out these forms and minimize potential errors. And then we've also started providing, for simplicity, a research plan. Let me see if I can open this for you. It automatically downloads as a Word doc so that students can use it just to start entering their own material. Let me share that with you. But this walks the student through creating a research plan. A research plan should be written in future tense. It's a plan for what will happen. There are subsections that can be included or deleted as needed, like human subjects, hazardous materials, etc. But it's nice because it includes, through prompts and questions, the material that the scientific review committee folks are looking for. So if you're following the template research plan, you will have usually an easier time of clearing scientific review committee review ahead of competition. Okay. Let me go back to my slides. I'll just show folks who are less familiar. The ISEF rules and ISEF forms are all available on their website as well. This big logo, Society for Science, is the organization that runs this science competition and a few others. But our QR code goes to the students page of the OSSEF website. That's all I wanted to share. Nicole, if you wanted to add anything, please do. Otherwise, we have a few minutes if folks have questions.
I have one.
Hmm.
So we are teamed up with our local butcher shop. Those
Hmm.
animals, we're going to utilize stuff after they've been harvested and stuff.
Hmm.
I just want to make sure that we're clear and everything's good on that. We're going to look at some of the studies about them and that part of it.
Yeah, that should be fine. That would be a tissue project, but it should not be a vertebrate animal
Okay.
project. And I'll double check. Nicole and I are doing our best to learn all these rules, as you can imagine, like everyone. But I'll make a note to double check that. And if I'm saying it wrong now and need to clarify, I'll send you a
Okay.
note.
We figured we was okay because they're doing it all, and then we're going to get the stuff after everything's
Right.
processed, and they do it all before we do it. So
Yeah. Yep. Yeah. And that's a great example. We always are trying to encourage teachers and students to think about projects that can be built based on what is available to you. Mhm. All right, well, thank you again. We're here throughout the fall as projects are coming together. Nicole and Dr. Stacy Thomas and some others are operating within our larger OSSEF Board of Directors, our education committee with kind of outreach events like this and others, essentially to provide as many resources and support as we can for participating in the fair, but also thinking about how we can use the fair and the system of science research going on around our state for these students to elevate their co-curricular experiences in STEM. And so we are grateful to have the opportunity to do that and to have your all's buy-in and we welcome feedback and conversation to keep that going. Thanks, everyone.